Hi, and welcome to this next tutorial on using Pecan software. So in the last tutorial, we saw how to actually process an image. In this tutorial, we're going to see how to run statistical tests and generate graphs. So uh, I've provided a decent amount of sort of sample data. So first things first, let's kind of take a look at uh, the processed image from which this data comes, just so you can kind of get a sense of what exactly it is you're looking at. So this is the process data set, and as you can see, it's basically the same kind of image that we processed in the previous tutorial. The only difference is I went ahead and did all the fancy analyses on it. So we did single cell tracking, and you're looking at here is these individual cells are each marked with sort of a uniquely colored badge. So if they're in the border region, we give them a red badge. If they're in the center region, we give them a blue badge, and each individual cell is uniquely color-coded. And as you can kind of see, they'll be tracked in 3 dimensions. See this gray one here. Notice that it perdures for a number of z-planes. And the yellow line there is just showing the distance from that cell to the clone border. So how close is a given cell to sort of the winner cells? And don't be worried that not every single cell shows a yellow line. It's only going to do it once per cell, kind of at its center of mass. And we also did the same thing with our cell death metrics. You'll see that again, these guys have the yellow measurements covering the distance to the border there. There's also a measurement for the distance to the sort of the center of the pouch, or the centroid of the region of interest. And we do that as well for the individual cell counts. So for each cell, we've basically got its position in what z-plane it's on, how close it is to the winners, how close it is to the centroid of the pouch, and all sorts of other properties. So we have for each of these cells, we have their sort of population parameters and kind of their individual parameters. And we can also analyze individual clones. Or, for instance, as you can see, like that's a discrete region, that's a discrete sort of clone, that's a discrete clone. These aren't true clones because I think these have probably fused together given these conditions, but I'm just kind of showing you how this analysis would work. So we can treat that separately from that. And here you see there's just kind of a color-coded mask showing you where they all are. And these sort of white blobs with the outlines, that's just showing you where the cell death is in these individual cells. And they are all sort of individually numbered. And we also, over here, we have an overlay kind of showing you how good of a job it's doing. And as you can see, at this particular z-plane, these two clones aren't touching each other, but they're labeled as the same thing, and that's because if we go a little bit deeper in, we see that they touch later. So we do account for sort of merging and fusion events. And so this is going to produce all the data that we used, all the data that is provided in the sample data space. So we have a few different types of files that can be generated by this software. So first things first, let's go and launch the analysis web page. You can also run it locally in RStudio if you have that. Just go to this URL and it'll load up all nicely for you. So the first thing we got to do is upload some data sets. So the basic data, the basic analysis, the sort of most fundamental one, are going to be these CSV files here that are called your whole disk analysis. And this is the whole disk analysis is your just general sort of population level data. So for the whole image, data for kind of everything lumped in together. So we can upload these whole disk analysis data sets, and you can upload as many as you want at a given time. The only condition is they have to all be formatted the same or of the same type. So if you've done the same analysis, you can upload as many of those CSV files as you would like. So once they're updated, just come and click Assign Experimental Conditions. And what you're going to see is all of the file names. telling you where which file these images come from, and then within those files, the individual image name. And then we just have to group them by experiment. So I kind of had labeled mine by images. That's how I kind of separated them up into experimental groups. So let's say this is yellow-white, which is my control genotype. And then some are expressing an RNAi against ref2p. And once we're happy with all the with those assignments, we come over here and we click Analyze. So we can also kind of group these guys together based on an experiment. So for instance, if I had done this experiment multiple times and I did like 3 independent replicates, I could say replicate 1, replicate 2, replicate 3, and they would be independently grouped together and analyzed independently. Or if I was doing a screen, for instance, I would say like, oh, week 1 of the screen or week 2 of the screen. So this is just your experimental grouping. This is your condition or genotype or drug treatment. And once that's done, click Analyze. And you'll see that all of this data has just basically been run through sort of a preset R script and all been analyzed. And you can see the results of that analysis over here in the Analyzed data table. And you see there's like all these different parameters. What's the volume of the loser clones? What percent of the clone coverage of the ROIs is there? And if we just want to look at a few of these parameters, we can come down here and click, say, these are the ones I want to look at, and however many rows of data you want to show. That data has all been analyzed. Now we just have to choose what kind of plot we want to make and which variable we want to analyze. So I can do like, say, a dot plot, a violin plot, or a histogram, and depending on which type of plot I choose, the other fields will update to make sure that it's all kind of valid. So let's look at the percent clone coverage of the pouch or of the ROI. And this will do, the parametric sort of assumptions testing will be done for us, but I've done this experiment enough to know that almost always it meets parametric assumptions. So let's just do a t-test and a hedges G effect size. And since this is just a single comparison, we don't need any P adjustment. And when we're happy with all that, we just click Generate Plot. And there you go. The analysis is all done for you. So it's made here a box and whisker plot. Each dot corresponds to a single image or single sample. And then we have up here the p-value and the effect size metric between your two conditions. And as you can see, this is not quite significant. Even though the clones are a little bit smaller for ref2p, it doesn't quite hold up. So then we have a bit more details. So we have in the statistics output, we have sort of more information provided, like the confidence intervals and details of what's been done. And we also have some parametric assumptions testing. So if you're going to do a non-parametric test versus a parametric test, you should make sure that your data is normally distributed and there's equivalence of variance, and we can see the sort of parametric assumptions for doing a t-test have been met. So this is basically a complete analysis, and this data is good, but we can change and look at, say, a different parameter. Let's say the foci density in the border. So this is just the density of sort of caspase positive cells in the border. Let's see if there's a difference there. This metric typically is, or let's do the percentage. This is going to tell you, this is going to be what percentage of cells in the border are dying, what percentage of cells in the border are dying. This is usually, not always, but it's usually kind of violates parametric assumptions. So I'm going to go with a non-parametric test, but let's check. Actually, it doesn't quite violate parametric assumptions, so we can do a t-test, but it's beside the point right now. As you can see, there's no significant difference. So it looks like this RNAi isn't doing a whole lot. But also, like, say that you've got this data, once you've finished analyzing this data and you're happy with it, you can actually customize this graph and export it for publication. So here are all your options. So if we want to change the title, so here's just the default title, let's say. And let's change the color of the fill. Generate the plot again. And there you go. We've changed our title and we've updated the fill of our sort of the fill colors. And there are all these different options you can play around with. If we don't want to display the effect size, in this case we don't really want to because it's not significant, so we really shouldn't be doing the effect size metric. And that'll be hidden. So you have a lot of options that you can sort of play around with here. And when you're kind of happy with how it looks and what how it's doing, you can download the plot here, and you can just sort of adjust its size. And this is in inches. Make it a bit smaller. And there you go. This is the sort of exported plot. And this is being exported as a PDF. So if you open it up in Illustrator, you'll actually be able to, these will be independent objects you can mess around with. So like you can change that text or, move these dots around or customize it however you would want to in Illustrator. So it's a publication quality graph. And that's how you run a basic analysis.